We are in Unit 2. We are doing still, oh my gosh, equations. Is this day 1004? What day are we on?
We are on 11.
Day 11.
My gosh, day 11. It's been going on forever. Now, before I write what we're doing, promise me that you will not freak out, because I think some of you will. So why are you clapping? That's not promising me, you're just clapping.
Why do you tell us not to freak out? Because it makes us want to freak out.
No, it doesn't. It's fine. So, I'm right. Don't worry about it. We are doing fractions. No, don't go.
Fractions.
Yes and no. So Haley said, hey, aren't we already doing fractions? Kind of. And if you can't see the board on the video, we'll figure it out because the lights are off, because our lights aren't working. But just in our room. Everybody else's lights seem to be working fine. But don't worry, Mr. Reeves is on it. Look, covering it. Covering myself. That's why the lights are off. Here we go. So, listen, here's the most important thing. We cannot use mixed numbers. That's the number one thing that you need to know. We cannot use mixed numbers. If there is a mixed number in a problem, you are going to have to change it immediately to an improper fraction. Improper fraction. So here's my mixed number. 3 1/3. Step 1 is to take the coefficient times the denominator. We're going to multiply. Then we're going to take that product and add it to the numerator. So it looks like this. 3 times 3 equals 9. 9 plus 1 equals 10. Then we keep the denominator that's given, and it gives me 10/3. You have done this years upon years upon years upon years upon years. At least for 2 years. But I think closer to like 4. Okay? Can everybody see the board? A little bit. If you need to see the board, come on up. So if you can't see it and you're in the back, I know the lights are off, but you can come up. Let's try a lighter marker. Maybe something else will work better. So let's try another one. Let's say I've got 4 5/7. Does the orange show up a little bit better?
Yeah.
Yes? No? Okay. So, again, I'm going to take my coefficient times the denominator. Then I'm going to take that product and I'm going to add. So, I take 4 times 7. I don't want to use an X. 4 times 7 is 28. 28 plus 5 is 33. Keep the denominator, it's 33 divided by 7. Questions? We are going to start with one-step equations. These are not hard. Okay? Truly, these are not hard. So this is changing it to an improper fraction. Multiplying. Okay? If I want to multiply fractions, let's say I've got 6/5 times 4/3. Actually, let's make it 4/6. I know, it's funky. Here's what I need to do. We multiply across. The numerator times the numerator, the denominator times the denominator. 6 times 4 is 24. 5 times 6 is 30. Am I done?
No.
Why not? Because we've done this several times now. What do I have to do?
Simplify.
Simplify. What goes into both 24 and 30?
3.
Okay, let's start with 3. 24 divided by 3 is 8. 30 divided by 3 is 10. Am I done there?
No.
Because why? What tells me that I'm not done? Maya? They're both what?
Even numbers.
Even. What can we divide it by if they're both even?
2.
By 2. So I can divide both by 2, which gives me 4/5. That's simplified. You will have to simplify fractions. Question so far. Is anything tough yet?
No.
I promise you, this is easier than decimals. Please trust me. Because that sounds like something a trustworthy person would say. Hey, just trust me. I tell my wife that all the time. Just trust me. I don't tell my girlfriend that. Don't worry, though. I'm just joking, honey. Hey, I love you. I'm just joking. It's all right. It's a joke. Okay, here we go. Ready? So here's our first example. And it's going to say solve. We've got 3/5 x equals 6. And you know a word, but I'm going to reinforce it today. When we have a fraction getting multiplied to the variable, anytime that we have something smack dab up against the variable, it means multiplication, right? Our inverse is division. Can we divide by a fraction? Not really. So instead of dividing by a fraction, what do we need to do? Does anybody remember? We're going to multiply, but multiply by what?
A decimal?
Not a decimal. You could change it to a decimal, but that's a lot of work. It starts with an R. Oh, this would have been good on a pirate day. Megan, the reciprocal. So when I multiply, first off, here's my balance point, right? We need to get the x by itself. So I need 1x. So I'm going to multiply both sides by the reciprocal of 3/5, which is what? 5/3. If I do it to this side, Carly, what else do I have to do? Do it to the other side. Why does this work? What is 5 times 3? 15. What is 3 times 5?
15.
What is 15 divided by 15? Oh, wait, it's 1? 1 what? 1x. Because that's our goal, is to get x by itself. What do I have to do on my right side, though? Go ahead, Gracie.
Don't you need to put a 1 under the 6?
Very good, honey. The 6 is really 6 over 1, right, Maddie? Yep, can you see it?
Kind of.
Then why don't you move on up? Okay, so now I'm going to multiply across. 6 times 5 is 30. 1 times 3 is 3. Am I done there?
No.
No. What is 30 divided by 3?
10.
So x equals 10. Is that hard?
No.
It's multiplying by the reciprocal. Will I always get a whole number? Not always. Sometimes you'll have to simplify. But right now I'm going to try to give you some problems that are not that hard. So let's go with another one. Let's say we've got 7 minus 3/2 x equals 12. Now we're getting a little bit trickier. We're now up to a 2-step equation with a fraction. Still not hard. Find your balance point. Remember, the goal of any equation is to isolate the variable. So Mason, if I'm trying to get x by itself, what do I need to move first? What do I need to move? If I'm trying to get this by itself, right? What number's on the same side as it? What's on that left side with it?
7.
So I have to move the 7 first. How do I move a positive 7, Mason? What's the opposite of positive 7? Very good. So I'm going to subtract 7 from both sides. Now remember, I circle my term with the x. Okay, because that's going to help me with my negative signs. 7 minus 7 is 0. All of this comes down, so it's negative 3 halves x equals 12 minus 7 is 5. The goal is to have how many x's? 1. So far I'm doing good in life. Only one ex-wife. I'm crushing it. From here, now what? Can I divide by a negative 3 halves? Go ahead, Gracie. Okay, so I have to multiply by the reciprocal. What's the reciprocal of negative 3 halves? Evan?
2/3.
Just 2/3.
Negative 2/3.
Okay, has to be negative 2/3. Here's why it has to be negative. You ready, Caleb? What's a negative times a negative? Positive. We want a positive x. 2 times 3 is 6. 3 times 2 is 6. 6 divided by 6 is 1. This is the multiplicative inverse. So x comes down equals. How do I multiply across here? Maya?
Make the 5 into a fraction for 1 and
Put it as a denominator of 1. Go ahead. Now what?
you multiply.
Okay, what am I multiplying?
5 times 2 is 10, and negative 10.
Good, because it's a negative 2, so negative 10 over
3.
1 times 3 is 3. Can I simplify negative 10/3? No, nothing goes into both. So x equals negative 10/3. That's it. Questions on this? Is this hard?
No.
Can we try one more? That might be a little bit trickier because I showed you how to get these into improper fractions. What if I've got 3 and 1/7, actually let's go 3 and 1/4 x minus 3 halves equals 16 halves. Uh-oh. So now there's a couple fractions in there. Before we can start, we probably can't see this over here. Before we can start, what do we need to do with this problem first? Go ahead.
Don't you have to
I don't-
multiply 3 by 4?
So what you're saying is, what I hear you saying, is we need to take this mixed number and change it to what? Into an improper fraction. So that's 3 times 4 is 12. 12 plus 1 is 13. So that gives me 13/4 x. Yes, ma'am? Before we even do that with this, we need to change it to an improper fraction. If you want to start with the balance point, that's fine, but we have to make it an improper fraction. So that's one of the things that's not up there, because it's a little bit of a different equation. So I'm good starting with the balance point. I'm also good starting it here. Okay, does that make sense? Then I bring everything else down. Minus 3 halves equals 16 halves. We can only add and subtract fractions when the denominators are the same. We call those like denominators. So I'm going to add 3 halves to both sides. When we add or subtract fractions, the denominator stays the same, and we just add or subtract the numerator. 16 plus 3 is 19, equals 13/4 x. What do we do from here? Come on, I need some new hands. I need some new blood right now. What do we do to get the x by itself? Swill, what do you think, man? Multiply by what? What's the R word? By the reciprocal. If I've got 13/4, that is 4/13. And yeah, this is going to be a big number. That gives me 1x. So now I need to do 19 times 4. That gives me 6, 3, 76. 13 times 2 is 26. Do I want to leave it as 76 over 26?
No.
So what can I simplify 76 over 26 by? Are they both even?
Yes.
If they're both even, what can we divide by, Maya?
2.
By 2. So I'm going to come up here. 2 goes into 76. 3, 16. So that gives me 38. And then I'm going to do the same thing. 2 goes into 26 once. 3 times. So that's 38 over 13. So that's what's coming down. And this right here is as hard of a problem as you're going to get. That's it. You will have to simplify the fractions. Questions right now, because I see some blank looks and I want to make sure that we understand. The key to today is multiplying by, one more time, what's that word, Maddie?
Multiplying by the variable.
Not by the variable, what's that R word?
Reciprocal.
Reciprocal. Reciprocal means flip it. So put the numerator into the denominator. Questions here. We will be spending another day